Good afternoon, everybody. My name is Ferhan Mazher, and today we are. I am with the 9 Cambridge class, and we are studying this first chapter. The name of the chapter is the Quadratic Equations. Today, we are working on the exercise 1A, and we are on the third question. The question is about converting the given quadratic expressions into this form x plus a whole square plus b. So we will learn how to represent this given expressions in this form. The given expressions are in the form of quadratic. Quadratic means that the power of the variable is 2, the maximum power of the variable is 2. So on your screen, you can see a question which is showing up. The expression is given, it says x square plus 12x, and we want to convert this into that form. So the method is very simple. What you do, you take that we have x square term, and then we have a term which has x with it. So take that term which has x with it, which is here 12x. In your rough work, take that 12x and divide it with the 2x. And whatever the answer you get, take its square and add that square in that expression and also subtract it. So here I have done that x square plus 12x plus 6 square minus 6 square. When I divided 12x with the 2x, I got 6. I will take the square of this 6 and I will add it and I will also subtract it. So if you look at these first two terms, and if you have a very good grip on the factorization, you will know that this is x square plus 12x plus 6 square. This is basically x plus 6 whole square. So this will close and it will become this whole square, x plus 6 whole square, and this minus will remain minus, and this will become 36. 6 square will become 36. I hope that you have understood this. We will practice 2, 3 more questions on it. So, do you understand this?
Yes, sir.
Okay. So, I please write this in your copies.
Sir, done.
Done. Okay. So we will do the next question. Let me take the photo of that question, and then I will share it with you. Okay. We will have another question, the B part. This question is exactly the same question, and let me show. Okay. So hopefully this is now showing up on your screen. This is the next part, question number 3B part. Here you can see that the x square minus 6x plus 1 is an quadratic expression, and they want you to represent it in that given shape. So the methodology is very simple. What you do, you take the term which has x in it and you divide it with the 2x. So in my rough work, I will take 6x and I will divide it with the 2x. So you see x and x will be cancelled, 6 and 2 will be cancelled, so you get 3. So take the square of the 3, add that and subtract that. And then you will do plus 1. This plus 1 was already there, so I will write this also on the extreme right hand. So this x square minus 6x plus 3 whole square, because here I have a negative. So this will become x minus 3 whole square. This minus 3 square, this will become minus 9. This minus will remain minus. 3 square is 9 plus 1. So this will come as it is, x minus 3 whole square. Minus 9 plus 1 will be minus 8. Kindly, if you have understood it, kindly write this in your copy. When you are done, kindly let me know.
Done, sir.
Done. Okay.
Done, sir.
Okay. The procedure is very simple. Okay. We take the middle term which has x with it, we divide it with the 2x. Whatever the answer comes, we take its square and we add it and we subtract it. The square of that thing, we add that and we subtract that. Okay. So I'm doing the next part and let me let give me just 1 minute. Uh, okay, here we go. The next question I'm going to bring. If you are done with that thing, see, for doing these questions, you should have a very good grip on the addition and subtraction of the fractions also. So here we have question number three, C part. This says x squared minus 3x minus 2. The methodology is very simple. What you will do, you will take the what you will do, you will take the term which has x in it, and you in your rough work you will divide it with the 2x. So in the middle, so the term which has the x in it is 3x. So I will take the 3x and I will divide it with the 2x. X will be cancelled, so you are left with the 3 by 2. I will square it. 3 by 2 whole square, I will add that in my expression and I will also subtract it from my expression. So you can see here I have written that x square minus 3x plus. Here is that square which I added. And I also subtracted that 3 by 2 whole square. So minus 2. So these first three terms, because here I have a negative, so in the middle I will write the negative. So this becomes x minus 3 by 2 whole square. This minus is still here. 3 square will be 9. 2 square will be 4. This minus 2 will be here. So this x minus 3 by 2 whole square will remain as it is, minus 9 by 4 minus 2. I will make the denominator same and I will add this fraction minus 9 by 4 and minus 2 and the answer will be minus 17 by 4. I hope you know how to add the fractions.
Yes.
Okay. So kindly note this in your copy. This methodology is very, very important. Okay. Just let me note down the next question and the D part, that's x squared plus 9x minus 1. Okay, let me change. So you can do that in your copy. Kindly do that in your copy. So I will work on the next question. I hope you have done in your copy. So we are moving to the next question. The next question is showing up on your screen. And here we go. Hopefully you can see this. Let me freeze. to this maximum size. Okay. So okay, so we are on the question number three, D part. You have x squared plus 9x minus 1. They want you to represent this expression in the required expression form of the expression. So what I will do, the technique is very simple. I'm repeating that technique again and again, so it is you get master of that. You become master of that. Okay, so we have the term which has x, that is 9x. I will take this in my rough work, and I will divide it with the 2x. So when I will divide 9x with the 2x, x will be cancelled. 9 by 2 will be the answer. So whatever is left after the division, I will square it and I will add this in my expression, and I will also subtract it in my expression. So I will add 9 by 2 whole square minus 9 by 2 whole square. You see here I have added this and I have also subtracted it. This minus 1 was already in the expression. So these first three terms, this will become x because here I have a plus sign, here I will have a plus sign. 9 by 2 whole square minus, this becomes 81 by 4 minus 1. So this bracket will remain as it is, x plus 9 by 2 whole square, and minus 81 by 4 minus 1. If you know the fractions, addition and subtraction of the fractions, I will take the LCM, or in other words, you can say I will make the denominator same, and the final answer will be minus 85 by 4. Let me note down the next one, and then you can continue the E part. Let me say x squared plus 1 by 2x. Okay. So kindly do this question in your notebooks. When you are done with that, and let me know.
Sir, done.
Okay. Okay.
Done.
Very good. 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 I'm doing the next one. Just give me a minute. I will bring in the photo. Okay. If you are done with this, let's get to the next question. Okay. So here we have. Okay, so this is the E part on your screen, x squared plus 1 by 2x. A little tricky question. The basic thing is same, but the only problem is it involves fraction with the term which has x. So my method is exactly the same. I will take that term which has x in it, and I will divide it with the 2x, because now fraction is involved. I'm using this technique. So you see x by 2 divided 2x. So this is what you have to do. You take the term which has x in it and you divide it with the 2x. So when x by 2 as it is, when I convert this divide sign into multiply sign, you know this second fraction is supposed to be reciprocated. It should be flipped. So it will become 1 by 2x. Now the numerator will multiply with the numerator and denominator will multiply with the denominator, and numerator and denominator, if they can be cancelled, they will be cancelled. So this x and this x will be cancelled. So you are left with 1 by 4. So it's very important that you understand the work which I am doing here in the rough work. So now you got 1 by 4. So I will take the square of 1 by 4 and I will add it. I will add this in my expression, and I will also subtract it from my expression. So here you can see I have written x squared plus 1 by 2x plus 1 by 4 whole square added minus 1 by whole square. So these first three terms, because here we have a plus sign, so this will become x plus 1 by 4 whole square. This minus will come as minus 1 square is 1 and 4 square is 16. What you say? Kindly do that in your copy. In the meanwhile, I will do the next one. Let me show you what you are doing. Okay. Kindly do this in your copy. You can also confirm the answers because if you have your books with you, are you done with this?
Yes, sir.
Okay, so here's the next question. Okay. Okay. So this is the next question. This is question number 3, F part, and it says x square minus 2x by 9. So this is a quadratic expression, and we want to convert this into a certain form. The technique of this is very simple. What we do, we take that term which has x in it in our rough work. The term is 2x by 9, and I will divide it with the 2x. So because this 2 by 9 is a fraction, so I'm using this special technique. You can see here in my rough work, you can see I write it like this divided by 2x. So it is 2x by 9. When I convert this divide sign into multiply sign, this second fraction flips. It reciprocates. So it becomes 1 by 2x. This 2x and 2x will be cancelled. So you are left with 1 by 9. So whatever you are left with, you will square it and you will add it at the square of that thing, and you will also subtract the square of this 1 by 9 from your expression. So you can see here we have written x square minus 2 by 9 x plus 1 by 9 square minus 1 by 9 square. So these first three terms, they will make the formula. This is the formula for the whole square. This is x minus, because here I have a negative sign, so here I will have a negative sign. So x minus 1 by 9 whole square. This minus will come here. 1 square is 1, 9 square is 81. So you can see we got this form. What you say? Do you understand this technique?
Yes, sir.
Okay, very good. Let me note down the next question and then you can do this in your copies. So we have question number 3, G part, that says x square plus 0.2x. Okay. So kindly note down that question in your copies. And meanwhile, I will do this. Okay. Are you done with this question?
Yes, sir.
Okay, so let me bring the next one. Here we comes. Here comes the next question. Okay, so let me increase the size a little bit. So, okay. Now on your screen, the question is showing that is question number 3, G part x squared plus 0.2x, and here we have he's trying to confuse you. He has given you a decimal fraction. So the method is still the same. We look for that term which has x in it. That's 0.2x here. So I will take this in my rough work and I will divide it with the 2x. So when I divide 0.2x with the 2x, so I will get 0.1. So the square of the 0.1 should be added and the square of the 0.1 should be subtracted from the given expression. So I wrote that expression, then I added 0.1 square, then I subtracted 0.1 square. So these first three terms, sorry, this is plus sign. So here I will have plus sign. So 0.1 here. So this will be bracket x plus 0.1 bracket close whole square. This minus will come as it is. When you take 0.1 square, it will become 0.01. You can do that on the calculator. 0.1 square is 0.01. Hopefully you understand. Kindly note this. Let me note down the next question and then you can let me note down the next question and then you can do the okay. So please note it down in your copies. When you are done, kindly let me know.
Done.
Okay.
Done.
Okay, Bitya. Shabash. You are done. So let's bring the next question. So here we have. So, but question number 3, part H is showing up on your screen, and it says x squared minus 1.4x. The it's an expression. It's a quadratic expression. So what we will do, I will take the middle term, sorry, the term which has x in it. I will take that in my rough work and I will divide it with the 2x. So 1.4x divided by 2x, x will be cancelled, and 1.4 divided by 2, that will give you 0.7. So whatever is the answer, you will take its square, you will add the square of that 0.7 in your expression, and you will also subtract the square of the 0.7 from your expression. So you can see I have written here x square minus 1.4x plus 0.7 whole square minus 0.7 whole square. So these first three terms, they make the formula of the whole square. So because here we have minus, so I will write a negative here. This is x minus 0.7 whole square. This minus will come as it is. And 0.7 square, 0.7 multiplied 0.7, that will give you 0.49. Kindly kindly note it in your kindly note it down in your copy. I will show that question. I was just noting down the next question. Yeah. Please note it down in your copies.
Yes, sir.
You're done.
Done.
Okay. Very good. Okay. I'm doing the next one. Just give me a minute. Anybody has a calculator with you?
Yes, sir.
Okay. Uh, just do a calculation for me.
Okay, sir.
Give me a minute. Uh, on your calculator, write -1 plus under root 6 equals to. -1 plus under root 6 equals to. What's the answer?
1.44.
1.44. Okay. Do another calculation.
Okay, sir.
-1 minus under root 6 equals to.
Sir, minus 3.44.
3.44. Okay. So you got the answer. Okay. So before I go to the next question, and which is the next stage of this technique, let's talk about this, what we were doing actually. The technique which we are using, this is called completing the square. Okay. This technique is called completing the square. Always remember this name, completing the square. But whenever this question comes in your paper, the examiner will never be using the word completing the square. Okay? So it's very important thing. You see, the question number 3, which we did, we tried to learn a technique. The name of the technique is completing the square. It's very rare that they will use this word completing the square. Whenever this question comes in the paper, this is the question they will ask. They will ask you to express the following expressions in the form of this: x plus a whole square plus b. Okay? They will never use the word completing the square. Okay? Anybody?
Okay, sir.
Okay, sir.
So whenever they want you to do this, they will always be telling you to represent your quadratic expression in this special form: x plus a whole square plus b. Maybe sometime, maybe I have never seen it. They may ask you to apply that completing the square. Okay. So the technique which we were using, that is called completing the square. So try that at your home also. Try to do that technique again. Um, when you apply that technique, there are few things which are very important. One thing is that I suppose that you are very good uh, at converting. If you are very good at taking the whole square, you remember the whole square formula is a plus b whole square is equals to a square plus 2ab plus b square. And another formula we have is a minus b whole square, that is equals to a square minus 2ab plus b square. You have studied this in your 8th class. Okay. Here, what we are doing is we have that expression and we close them and we make the formula. For example, a square plus 2ab plus b square is given to us and we close it and we write a plus b whole square. So hopefully you understand this. If you do not get it, we will do this the The explanation I will do in my class. Okay, so we are moving to the next question. That's question number 4. And in the question number 4, it says x squared plus 2x minus 5 equals to 0. This is not an expression now. It is an equation because it has an equal sign in it. So now this is an equation. So what we will do, he wants you to find out the solution of these equations. That's the question. Have a look at this question. What they want you to do. Oh my God. Okay. So let me show you the question. That's the question is find the solution. Okay. So I have closed all the windows. Okay. So let me down again. So when they ask you to do find the solution, it basically means they want you to find out the value of the variable. They want you to find what is the value of the x. When they want this, they use the word solve this equation. Means you are supposed to find out the value of the x. So here an equation is given x squared plus 2x minus 5 equals to 0. Whenever you solve a quadratic equation, till now you have already learned 2 methods to solve it. One method is first you factorize the quadratic equation, and then you make those brackets equals to 0. You have studied that in the chapter number 5 of the D2. If you look at the chapter number 5 of the D2, that whole chapter is about solving the quadratic equations. Okay, so you can do the factorization of that quadratic expression which is on the left side, and then once you have factorized it, then you can find out the solution. But hopefully the questions which will come up here, you will not be able to factorize them because their factors are not possible. Their factorization is not possible. So here we will use completing the square method. The technique which we learned in the question number 3, we will use that technique here, and we will not be able to factorize this. So this is the new technique. You will solve the equation by completing the square method. So try to learn it. Here we have x squared plus 2x minus 5 equals to 0. It's important that it should be equals to 0. Okay, so I will take that term which has 2x in it. I will take this to my rough work, 2x, and I will divide it with the 2x. I get 1. So this whatever the answer I get here, I square it, and I add this on the left side, and I also subtract it on the left side. So you can see here I've written x squared plus 2x plus 1 square minus 1 square. This is that thing which I was talking about. And minus 5 was already there, equals to 0. These first 3 terms, they make the whole square formula, x plus 1 whole square. You see, x plus 1 whole square will be x squared plus 2x plus 1. This minus, as it is, 1 square is 1, minus 5 is minus 5. So x plus 1 whole square minus 1 minus 5, that will give you minus 6 equals to 0. Take this minus 6 to the other side. When it goes on to the other side, it becomes plus 6. Okay. So now I have x plus 1 whole square equals to 6. I will take square root on both the sides. I will take square root on both the sides. So this square root and this square will be cancelled. You will have x plus 1. Under root 6, we can find out its value. Whenever you take under root, so I forgot to write here plus minus, but whenever you take the square, for example, I took the square root of 6. The answer will be plus under root 6 and minus under root 6. So now here I will have 2 cases. One is x plus 1 will be equals to plus under root 6. The other case will be x plus 1 equals to minus under root 6. If you remember the question number 2 of this exercise you have already done, There we were using this technique. Okay. So here x plus 1 equals to plus under root 6. This plus 1 will go on the other side. It will become minus 1. So x is equals to minus 1 plus under root 6. On your calculator, you will write minus 1 plus under root 6 equals to. And you will get the answer. That's 1.44. The other case will be x plus 1 equals to minus under root 6. So you will have x equals to, this plus 1 will go on the other side. It will become minus 1. So you will have minus 1 minus under root 6. On your calculator, you will write minus 1 minus under root 6. And the answer will be minus 3.44. So today I think we will be only be able to do this first part only because I don't want to stress you out. So kindly do this in your copy. Hopefully you have understood. We will continue this question because I want some part of this question to be done in the class. So we will do it in the class, the rest of the questions. But first, kindly do this question in your copies. When you are done, kindly let me know. So I was with the 9 Cambridge class. We were studying mathematics. We were doing the exercise 1A. And today we have done question number 3 and question number 4A part only. So thank you very much, everybody, and have a good day. God bless you all.